Welcome, ham radio operators. My name is Brian, WA5SON. Today's video is going to be over the East Coast Reflector. What is the East Coast Reflector? How does it work? What's all this talk about AllStar, IRLP, hams over IP, DMR, D-Star, cross mode? The list goes on and on. We'll even crack open an AllStar node, take a look at it. What's inside that magic box? Hope you join me and hang around. It's going to be fun. Let's talk a little bit about history first. So, ECR, short for East Coast Reflector, started way back with Dick, WB2JPQ, and all his friends were moving away. I mean, they would talk on the repeater on a regular basis, and they were all within, RF range, radio frequency range, of the repeater, and as they moved away, states away, they wanted to stay in contact. Well, HF is not always reliable as far as an effective mode of communication, and repeaters only go so far. So they look to IRLP, or Internet Radio Linking Project, and it sounds exactly the way I explained it. Linking radios through the internet. So essentially taking a repeater example down in Florida and linking it via the internet to New York, for example. Now both those repeaters are linked together, and it's like you're talking on the same repeater. And that's essentially how it started. Started with a very small system, and it grew. It grew into more systems, more connections. That's where you get the AllStar and the D-Star and all those different connections. So let's get into a little bit about how the East Coast Reflector works. It's network, because that's essentially what it is. It's a network of various modes linked together to create a reflector. So what you're seeing here is this is an image off the East Coast Reflector's website, which I'll put the address here right up on the top. It's just pretty simple, eastcoastreflector.com. No spaces, no special characters. But what you're looking at here is the basic system. These are the entry points into the reflector. Now, something to remember about here, each one of these boxes has several other connections to it. So, for example, my repeater is connected to the East Coast Reflector through AllStar Hub 45225, which is down there on the bottom. And it links out to all those other boxes out there, the Echolink boxes, the IRLP boxes, the DMR boxes, and they all got to go follow those arrows. So I'm going to take you through a journey of when I key up my repeater that's over on 45225, what happens? So I key up the radio. So what essentially does, I key up that hub, that AllStar hub. And that AllStar hub down there in the bottom left, it keys up the other two AllStar hubs. Guess who's over there in those? More users, more repeaters, more connections. And then even then, those hubs, they have plugins. Echolink, Ham Shack Hotline, Hams over IP, IRLP Reflector, AllStar Bridge Nose. It keys all those up too. So if I pushed a button, I've already keyed up all those green boxes and all the people that are connected to those green boxes. But additionally, you'll kind of see that red box there in the middle, the bridge nodes. And it goes out to DMR, D-Star, Yaesu System Fusion, M17, and P25. All those are digital modes. So and even then, when I key up there, I'm keying up those systems too. And vice versa. Someone keys up on the DMR, they follow the path all the way back, and it gets to me. And that's essentially how it works. But the red box there in the middle, think of that as a translator. So essentially, analog can't talk directly to digital, and digital can't talk directly to analog. So there has to be something in the middle to do the translation from analog to digital and digital to analog. And that's what that bridge node is in there for. Essentially, that's a computer. A node is essentially a computer. You may be hearing that all the time. Nodes, hotspots, things like that. They're all just computers with radios linked to them, or some sort of audio interface linked to them, so you can get audio in and out, and you can control that computer, push to talk, things of that nature. So in a real high level, this is kind of how it works. Let's go take a look at how broad the system actually is, and I'm going to show you an eye chart that's going to make your eyes pop. So what you're looking at here is what they call an AllStar bubble chart. We ping AllStar and be able to see who's connected to what hubs at very specific moments. Each bubble represents a connection. And the blue bubble down there, you can't really hard to see, very fine print. That's my repeater, and it goes to that hub, that middle bubble, and then that hub goes to another bubble. So these are all the bubbles all over the place. But so let's go back through that path again I was just talking about. So here I am. I'm over here. Here's my repeater. I'm on 441.900. So when I key up my node, when my node starts sending traffic into the network, it goes over to the hub. You saw that over there in the diagram. So here's the hub. So something to remember about the hub is all these other connections, I have just keyed those up too. So Alabama, New York, Maryland, here's another Texas. I mean, they're all over the place. It's whoever connected to this hub. Additionally, there's another hub, so that's the hub that I just keyed up, right? It goes over to the other hub, and it does the same thing over here. It keys up this hub. And all these connections, North Carolina, Washington, Topeka, Kansas, and then it also goes over to this hub that's way over here. It keys up this one too. So there's 3 individual hubs, and we got Florida and PA and some other places in there. So that's essentially what happens is it's going down the chain, and it's keying up all these node radios or nodes or hotspots or however you want to refer to it. It's keying them up. I'm keying it up when I push to PTT, and vice versa. Whenever they key it up, they're keying up my radio, and I'm hearing their traffic, vice versa. So this kind of goes all back and forth. So that's what that's what the East Coast Reflector looks like from a bubble chart perspective, from a visual context perspective. But I'll tell you a secret. That's not even all of them, because some of them aren't even displayed on here, because this is just showing the AllStar. It doesn't account for the Echo Link. It doesn't account for the all the digital people that are connected up. So these is just a sampling of some of the connections. Okay, so now that you understand how the East Coast Reflector works, how it's configured, let's bring it down to a level. Let's bring it down to a node level, and let's crack open a node. I'll crack open my AllStar Simplex node, and we'll take a look at it and see how this thing actually works. Okay, so now we're peeking inside the magic box. This is an AllStar node. Now, this is a simplex AllStar node, but in the repeater world, it's pretty much the same. Repeater just got another radio and other hardware components in order so it can transmit and receive simultaneously. It can repeat. Simplex node can only receive or transmit. It can't do both. That's the main difference between them. But whether it's AllStar or you may have heard the terms hotspot, Pi-Star, MMDVM, a bunch of different terms out there. Think of this as on a component level, because they all got to have the same basic components. They run different software, different hardware, yes, but they all got to have the same components, and that's what I want to show you here. So you're looking at the inside of the node. We'll go over the bits and pieces that are in here. On the left hand of the screen, you're seeing my interface to control this node. So how do I control this node so I can perform different functions, to connect to the East Coast Reflector or disconnect to the East Coast Reflector? How do I know what I'm connected to? You can do a lot of different things. All right, so let's go back over to the camera and let's look at these components. So we need a brains. We need a brain of the node. So in this case, we're using a Pi 3B+, which a Pi 3 is just a small single board computer. The Pi 0, which is also a small single board computer, and less power, less computational capabilities, it's still a brain. Now, this is the thing that controls everything, and it does it via software. And in AllStar case, we're using ham VoIP, which is the piece of software to run AllStar. Pi-Star is another piece of software for digital modes, DMR, Yaesu System Fusion, D-Star, and the like. It's a piece of software running on those particular ones to run those particular modes. But bottom line, it's software, so the node has a brain. All right, and then you'll come over here. You'll see this guy, this little hanging out on this side. What that is a sound card interface. So the brain, the computer, does not natively speak the language of the radio. It can't take raw audio and stick it right into the computer. It needs an interface to translate it to something that computer can understand. And we use a sound card interface. In this case, the CM108. But there's lots of different sound card interfaces, but they're all doing the same thing. It's taking that information and translating it to something that the computer can understand. And in addition here, what I'm also doing is I'm pulling out some control functions so I can key up the radio, the transceiver that's inside the node, and also the radio can tell the computer when it's hearing traffic, when I'm keying up the radio on my handheld. All right, so that's the sound card interface. This little guy down here, this is just a simple buck converter, BUCK, and it converts 12 volts down to 5 volts because that's what the computer needs, and the transceiver needs a lower voltage than 12. Okay, so those are those components. Now, the Node radio, and just like with all the other ones, we have, I got a little handy talkie in here. So this is a Baofeng 888, and I see I have various wires tapped into it for audio, both transmit and receive, PTT, and what we call COS. COS is just a fancy way of saying, how does the computer know that this radio right here is currently receiving traffic? It's got to know that it's doing that, so it knows to send that information over to the network. But the radio in the hotspot terms, you may have heard MMDVM. That's a common term. It's the same thing. It's a transceiver, but it's for digital. This one is an analog transceiver. So same basic components. Got to have a brains operation, a computer. Got to have some sort of interface between the radio and the brains in the radio, and then you got to have a radio too. But that's the basic components of a node. So let me pull this aside, and we'll get the handy talkie so I can show you kind of how it works. So let's pull this handy talkie over. So this handy talkie is currently tuned up to my simplex node, and if I key it up, you'll see where it says COS detected. So my node knows that this one is in transmit right now. So if you saw there, it said PTT keyed. So the node was keying up the radio in the inside the box to say, hey, I gotta send something out. In this case, it was doing my ID. It was doing my ID with my call sign. So that's essentially how it works. Let's go connect up to something, and you'll be able to see how it works a little more. We'll go over to the Parrot server.
Audio level is a little bit higher than average.
So it sounds like someone's already in there. But something you'll notice there is the blue line versus the white line. So blue versus white. Right now it's white, it's PTT key. But blue essentially means that, okay, I'm receiving traffic from the network. In this case, I'm receiving traffic from Dallas, Texas, because that's where I'm connected up to. When it's white, I'm not receiving traffic, but the node radio is still key because it needs to send things out. So you may hear this called local traffic, courtesy beeps. In this case, it was doing an ID, a CW ID, the connection notices, things of that. That information doesn't go over the network. That just goes over my node. But there's some traffic that comes over via the network, and that's the blue. So there's two different kinds of traffic that's being transmitted out of these nodes. It's either local only, or it's coming over the network. Now, you would only know this specifically if you were actually in the interface and be able to see what's going over the network and what's not going over the network. So if I give this just an audio check, you'll be able to see kind of how everything works. This is WA5SON doing a test on the Parrot server.
Audio level is pretty good.
This is WA5SON doing a test on the Parrot server.
Well, that's the whole process from beginning to end. Not too complicated. And so when I key that up, obviously I'm probably the only one connected up to this one, and we could go check by clicking the bubble chart. But it's a very small system. So as soon as I connect up to a large system like the East Coast Reflector, for example, when I would key up, all that traffic would go over there, and I receive their traffic. So why do we hear ka-chunking? So let's go take a look at some of the reasons why you might hear a lot of ka-chunks on the ECR. I can control my node through that interface I was showing you, but I can also control my node through my handy talkies. So for example, I can, if I want to disconnect, I could just do, and now I just disconnected. But what I did, if I was still connected to something, I was keying it up because I have to key it up to control my node. So that's why you hear ka-chunks, because some of these nodes, in order to control them, they might not be in a spot where they got direct access to the interface, and they can only do it from their handy-talkie. In the digital world, sometimes they have to do that to get out of a various talk group or disconnect from a network. So they have to key up the radio to control the brain. They have to transmit some information to it. In this case, I was transmitting DTMF tones. The digital side of the world, they do it slightly different, but they need to transmit some sort of information in order to disconnect from a various network that they may be connected to. Or they could use the interface like I was just showing you before. Interface, I don't have to transmit to the radio because I got direct access to it. So now that you get a good understanding of the East Coast Reflector, how it works, the network, a node, or hotspot, and how it's controlled, and some of the things like that, let me show you some tools available to you that you can use whether you're a node owner or not. They're really neat tools. You just go to eastcoastreflector.com, which you see here on the left-hand side. And on the right-hand side, that's the familiar my interface to my simplex node. But on the home screen, you can see who's talking. So right now, there is an Echolink station talking at this particular moment. They have my node keyed up. And before that, there was Leesburg, Florida. That's who had it keyed up before. And additionally, if you want to see more information, you just go to the ECR app, and then once you're in there, go to the Who's Talking. And when you're in there, you'll be able to get a little more information as far as who's talking. So same information, just in a slightly different format. But it's kind of nice to see, exactly who's talking, and you could go to the node. So for example, if I wanted to see, K4FCs, I could just click that link right there, and it'll bring me right to his node information, and I can look at that. So it's a really neat tool. So another really useful tool is for audio checks. Now, you'll hear it on the ECR where others are asking others for audio check. How does my audio sound? Well, there's a better way to do audio check where you can hear yourself, because who's better to do your audio check than yourself? You know how you sound and how good you sound, so why not do it yourself? And the tool is available to you. So let's go take a look at how you can do that. So if you go over to the Listen Live tab, and that'll bring it up over here, and you just press the play button. So when you press the play button, there'll be a 1.5 to 2 minute delay of the traffic on the East Coast Reflector. So what I'm going to do here is I'm going to do an audio check from my simplex node, and you can do this from a repeater or whatever access you have into the East Coast Reflector of what do I sound like coming out of the other end. And you can use the Listen Live button to do that. So let's do that right now and see how that works. This is WA5SON doing another audio check, listening live. No response required. Okay, so we'll press play here and we'll listen for it in about a 1.5 minutes later.
This is WA5SON doing another audio check, listening live. No response required.
So as you heard there, you heard me come up about a 1:45 later, and I can hear what it sounds like through my computer speakers. Now this will work through your phones. You don't have to go through the website. There's actually, you can come over here on the app and you'll get the same Listen Live button. Does the same sort of functions. So in closing for this video, I have a few other things I want to share with you that may help you. So first, if you want to dig a little bit deeper into the network as far as the information goes, on the left-hand side, under the monitors folder, there's a bunch of links here to some of the background information of the reflector. So for example, the AllStar Monitor Hub. So let's go over there and take a peek. And there's a lot of information. This, as I scroll down here, you'll see all the different connections, how they're all linked together, how long they've been linked together, when was the last time they transmitted. Some of them had never transmitted, so they've been connected, but they still haven't transmitted into the East Coast Reflector since connecting. So go ahead, start looking through this information if you're curious and you want to know. And there's links in here too, like IS nodes, for example, and you can click on the node number. There's links over in here. So there's a lot of information within the hub. The Supermon hub looks very similar to mine, except this has a lot more to it. But go ahead, go in here and start to explore. As you explore, you're gonna come up with questions. You're gonna be like, well, I wonder what that is. I wonder what this is all about. And we have a resource available for you, and that's the Zoom meeting. So whether it's something we covered here or something in general, it's a great place to ask questions. It's a great place just to put a face with the name, and it's the Zoom room meeting. So all you do is just come over here and you click the Zoom meeting, and it launches. You don't need any sort of password or anything. It just launches, and I bet you there'll be people in there right now. And there is, there's some people in there in the Zoom room at this particular moment, and they're having conversations about who knows what. So really, really cool tool. And then of course we always have the TechNet. TechNet's available on Tuesday evenings on the East Coast Reflector. Starts at 8 p.m. East Coast Standard Time and runs till about 10 p.m. Well, that's pretty much it. The only thing I have last to share with you is just the guidelines of operating on the East Coast Reflector. So there's one major things, two major things. One's for node owners and the other one's for everyone else. Let's cover the one for node owners first. So if you're a node owner, you have to be diligent in disconnecting from the East Coast Reflector before you connect to something or someone else. And if you do that, you're cross bridging. It's possible where you can get two networks bridged together. Now we have just one massive network, and things start to crash. So be very diligent, node owners out there, especially the new node owners, to do your disconnect command before you connect to the East Coast Reflector or before you connect to anywhere else. Just always make sure you do a disconnect command first. You saw me do that from the HT. You saw me do that from the interface. Just always make sure you follow that procedure. Okay, so that's for the node owners. How about everybody else? So everyone else, you notice that this network is vast, and I think I drove it home in this video that we need to be mindful of how big this system is. And this is where that 2 to 3 seconds pause between each transmission comes into place. Because remember, we were looking at those bubbles and all the various connections and the cross bridges into the digital side. So all that takes milliseconds in order to come up and come down. So when I key up, when I PTT into the network, I have to key all those up, and then when I let go, it's got to key them all the way down. So that's where the 2 to 3 seconds comes into place, and why it's so important that you do it. Because if you don't do it, then the first part of your conversation will be cut off. Or even worse, the timeout timers on the repeaters won't reset, and you'll essentially time out the repeater on several ends. So just wanted to share that with you so you're aware of why it happens. All right, so thank you for taking your time to watch this video. I know it was long, but I hope it was very informational for you. I hope you come away with a better understanding of a network system like the East Coast Reflector. And hey, hope to hear you on the air. And if you happen to hear me or just throw my call out there, I might be listening. I'd be happy to have a conversation with you. So this is WA5SON, and I'll catch you on the ECR.